All right, my topic is pedometers. My name is Lawrence Lamb, and the title of this article is Validity of Smartphone Applications by Kristen Orr, 2015. Background. Daily physical activity is important to the maintenance of mental and physical health. According to Orr, self-monitoring can be an effective strategy for increasing physical activity with smartphone technology. The accessibility of self-monitoring has become easier through pedometer applications. Orr felt that the importance of this study was given the growing popularity of smartphone use in everyday life and the promising accuracy of mobile phone technology in physical activity. If these applications are valid measures of physical activity, they could be a cost-effective and good substitute for researchers evaluating walking interventions. Orr felt that these applications could be beneficial for the general public in accurately self-monitoring physical activity, which is important for behavior change. The purpose of this study was to assess the validity and consistency of the three most downloaded pedometer applications available for iPhone, Android, and Windows operating systems. These applications were tested on a variety of phones and compared to a research-grade pedometer. Previous research indicates that the Yamax SW200 is the most accurate pedometer available, and it is therefore used as a criterion measure. Methods. 5 conditions were assessed: the 20-step test, the 40-step stair climbing, treadmill walking and running at different speeds, driving, and 3-day free living. The Yamax SW200 pedometer and observed step counts were used as criterion measures. Participants. A sample of 11 and 18 participants aged around 22 to 50 years old were recruited for the laboratory and free living test. All participants were given a written consent prior to taking part in it. Table 1 shows the participants' descriptions, their height, mass, body mass index, and age, presented as a group and by testing condition. The instruments used in this study was a variety of cellular phones: the iPhone 4S, the iPhone 5, the Samsung Galaxy S5, the Samsung Note, Samsung S4, the LG Nexus, and the HTC Desire, and the Yamax pedometers. Application mechanisms. To better understand the applications, researchers contacted manufacturers to identify how each application works, what phones the applications were compatible with, and how each application differed from other available pedometer applications. The AccuPedo only uses the phone's built-in accelerometer and its algorithm. The application is designed to work regardless of whether the phone is placed in the individual's pocket, the belt, bag, or is compatible with all smartphones. Moves uses GPS and accelerometer data in its algorithm. Moves is designed to work regardless of whether the phone is in the bag, purse, pocket, hand, or armband. Runtastic, the application works solely on GPS. Distance traveled is divided by stride length to calculate the step counts. The Yamax DG Walker SW200 uses a coil spring mechanism to count for steps. Once enough force is applied to the coil spring from the up and down motion of the hip girdle during gait, the lever arm deflects, accounting for 1 step. Figure 1 shows the percent error of each 20-step trial by device compared to the true count. The Moves application shows the highest percent error during this 20-step trial, followed by the AccuPedo and followed by the Yamax SW200. Figure 2 shows the percent error of each 40-stair climbing trial by device compared to the true count, with Moves showing the highest percent error, followed by AccuPedo, followed by Runtastic, and then the Yamax SW200. Procedures. The researchers conducted 4 tests of pedometer application validity: the 20-step test, the 40-stair test, the treadmill test, and the driving test. A convenient sample of young adults around the ages 21 years old was used for all laboratory tests. In each test, the mobile phone was held in the participant's hand and the pedometer was placed over the right hip. For the 20-step test, the pedometer and the applications were zeroed and the participant completed a 20-step test at a normal walking pace. Participants counted their own steps during the test, which was used as a criterion measure. Error greater than 1 step was considered unacceptable. For the climbing stair test, this test was given as a previous study and was enabled to accurately measure stair climbing using a step count application. Participants climbed 40 stairs, 20 ascending and 20 descending, one at a time without skipping steps or resting with both feet on a single stair. Participants counted their own steps during the exercise, which were used as criterion measure. Error greater than 2 steps was considered unacceptable. The treadmill tests were conducted on a wood-weight treadmill. Each participant completed 1 minute of walking at 2, 3, 4.5, and 6 kilometers per hour. The participant then completed 1 minute of running at 8, 9, 10, and 11 kilometers per hour. For the driving test, the participants were seated in a motor vehicle while driving on a paved surface for 0.2 kilometers at both 10 and 20 kilometers per hour. For the free living test, participants were asked to run all 3 mobile applications on their personal mobile phones for 3 days, a minimum of 10 hours during the free living trial. The same instructions were given for using the Yamex pedometer, and wear time was used to ensure each day of the data was valid, at least greater than or equal to 10 hours. Participants were provided with the Yamex pedometer, the criterion measure, and given a calendar type log to record all step counts from the applications and pedometer for 3 full days. The participants were given verbal instructions on how to properly wear and use the pedometer. Participants were encouraged to use their own mobile phone as they normally would to promote ecological validity. Table 2 shows one-way repeated measures of NOVA results between groups at each treadmill speed. Table 3 shows pedometer and application reliability presented as means and standard deviations of the percent error. Results. The 20-step test. For the 20-step test, the percent error of each trial was computed for each application in the pedometer to assess whether the error exceeded greater than or equal to 5%. All applications had an error greater than or equal to 5%. However, the Yamex pedometer showed the smallest error percentage, negative 0.7%. For the 40-step stair climb test, the percent error of each trial was computed for each application in the pedometer to assess whether error exceeded greater than or equal to 5%. Yamex and Acropedal had an error greater than or equal to 5%. Runtastic's error was negative 3.41%. For the treadmill test, video counts were compared to the application pedometer readings to determine validity. On 2 occasions, video software failure prevented counts being taken. Data was analyzed for outliers, normality, and sphericity. Runtastic scores at 11 kilometers per hour contained 1 outlier and were non-normal. For the driving test, data was analyzed for sphericity and homogeneity of variance. The data violated both assumptions and included outliers. Outliers remained in the data because of a small sample size. There was no significant difference between the step counts recorded by the devices at 10 kilometers per hour and 20 kilometers per hour. For the free living test, participants recorded an average of 12 hours of wear time. Data was found to be missing at random, and the expectation maximization method was used to impute data for each of the applications prior to further analysis. Figure 3 shows the percent error at each treadmill speed by device compared to the visual count. Table 4 shows a one-way repeated measures of NOVA showed each application to be significantly different from the pedometer. Limitations. The limitation of this study was that the evaluations were completed on a single participant and no free living condition was included. Using the Yamex SW200 as a control measure has some limitations, including overcounting inclined surfaces, stair steps, stride lengths, and its placement may be affected by individual waist circumferences. Researchers had difficulty with placement of the phone, and the study used a relatively small convenient sample of adults similar to other pedometer validations. Conclusion. The results suggest that the most commonly downloaded smartphone applications are not valid or consistent in measuring step counts. OR states that caution is required in relying on these applications for outcome measures of physical activity within intervention trials. Further research and development is required in improving the validity of these applications, and we anticipate that such improvement will likely come rapidly. Overall, this article was interesting to read and I learned a lot from it. I did not expect for the pedometers to have such a high percent error, and I expected the pedometers to be more accurate than the results showed. One way to improve the study was possibly using one type of phone rather than multiple types to test applications. Overall, it was an interesting article, but it changed my overall opinion on pedometers on smartwatches and smartphone pedometers. Here are the references for the study in the article.